I am Dr. Harish Ken, Assistant Professor, Department of Chemistry, Dayanand Sagar College of Engineering, Bangalore. Hi, welcome to the corrosion control session. So, implicit current method is the another method of cathodic protection methods. So, in this, at the end of this session, you'll be able to define cathodic protection. You'll be able to explain the mechanism of implicit current method. You will be able to enumerate the advantages and limitations of this method. So at the end of this session, so you will be able to differentiate. So what is sacrificial anodic method? What is implicit current method? So difference between sacrificial anodic method and implicit current method. Before going to this method, so we will discuss about the galvanic corrosion. Now all of you are familiar with when two dissimilar metals are in contact with each other in the presence of corrosive medium, the more active metal acts as anode and undergo corrosion. The thumb rule of this galvanic corrosion is anodic area and cathodic area are separated based upon their reduction potential of the metal. So this can be better understood from the electrochemical series. So the metal with lower reduction potential taken as anode and undergo corrosion, whereas the metal with high reduction potential act as a cathode. So and it is unaffected. So this can be understood in a better way using electrochemical series. Here you can see the metals are arranged in an increasing order of their reduction potential. Right. So if, for example, if you take two metals, copper and zinc. So copper and zinc are placed in a corrosive environment. Zinc has a lower electrode potential compared to copper. So that's why it is taken as anode, whereas copper has higher electrode potential. So it is taken as a cathode. So other examples are iron, zinc. In iron, zinc also. So zinc is anode because it is a lower electrode potential compared to iron. Iron has higher electrode potential. So total generally, so in conclusion, we can say the anode and cathodes are classified or separated or identified based upon their activity. More the metal is more active, it is taken as anode. The metal is less active, it is taken as cathode. You can see here is zinc. So zinc, titanium, aluminum, magnesium have lower reduction potential compared with other metals. So always these metals are very active metal. So always they are preferable for anode. So now we are moving to the implicit current methods. We will understand what is cathodic protection. The metal to be protected is completely converted into cathode, or we are forcing it into act as a cathode so that we can prevent the corrosion of the metal. So in implicit current method, so what we are doing, the metal to be protected. So it is a cathode. So undergoing corrosion. So is connected to an insoluble anode. Insoluble anode and current is passed using DC power source. So opposite to the corrosion current. So that the corroding metal gets converted from anode to cathode and is protected from corrosion. So in sacrificial anodic method, what we are using, so the sacrificial anode is used. Whereas in implicit current method, insoluble anode is used. Insoluble anode or inert anode. This anode will not take place in, so will not react in the during the reaction. So will not takes place in the reaction. So that's why. So this was the difference. So in and also in implicit current method, we are using a force source for the implicit current method to activate to takes place. Whereas in sacrificial anodic method, both metals are connected with each other. So physically, so through wire externally. So insoluble anode and insoluble inert anode. So what metals we can use? So generally these should be conducting materials. So which is not consumed, is which is insoluble anode or inert anode will not directly takes place in the reaction. So those are platinum we can use as a insoluble anode, graphite, stainless steel, mixed metal oxides, lead alloys, so platinized titanium, etc. These metals can be used as an inert anode in implicit current method. We'll understand this mechanism of implicit current method. So again, so the metal to be protected, our aim of this experiment is to protect the object from corrosion. Here the object is the metal to be protected is mild steel again. So mild steel, it may be pipeline, steel pipeline, storage tanks, so whatever it may be, this mild steel is buried under the ground. Now, so now we are supplying a power. So to in this experiment, in this method, we are supplying a power source. Negative terminal of the power source is connected to a mild steel pipe, and positive terminal of the DC power supply is connected to an insoluble anode. Insoluble anode may be platinum or graphite. This anode is called impressed current anode. In sacrificial anode method, impressed anode. There in sacrificial anode method, sacrificial anode. Here, impressed anode. Right. Now, DC power supply, negative terminal is connected to a mild steel. Positive terminal is connected to a impressed anode. So now the electrons are moving from DC power supply to mild steel. So automatically, so this mild steel accept the electron and get reduced. So reduction reaction taking place at mild steel pipeline. So therefore it is taken as cathode. So and at the same time, so impressed, so anode is, it will become, so this inert metal will become anode. So anode is directly will not takes place in the reaction. So whereas this cathode, so it accept the electron, get reduced, and this mild steel is protected. So it remains unaffected. So because it is a cathode, so that's why this is what the impressed current method. In impressed current method, metal to be protected is completely convert from anode to cathode by applying a DC power supply. This is what the simple mechanism. So let us see a complex mechanism. So cathode, so this is what the cathode, it is a less active metal. So metal to be protected, so this is what the, it is more active metal. When these two metals are in contact with each other, the metal which is having less active metal is taken as cathode. The metal which is having more active metal is taken as anode. Anode undergo corrosion. Right? When these two metals are contact with each other, so this metal will undergo corrosion. So because it is a more active metal, but actually we want to protect this metal also. What we can do? These metals are connected to DC power source. The negative terminal of the power supply is connected to so this metal, whereas positive terminal of the power supply is connected to insoluble anode like platinum or graphite. Now, when you are applying a current more than a corrosion current, so more than a corrosion current, what do you mean by more corrosion current? You take in this case, these are the two dissimilar metals connected with each other. So it is a more active metal and undergo oxidation reaction. It releases electron. Electrons are moving from this anode to this this electrode to this electrode. This is called corrosion current. You need to apply DC power supply more than this corrosion current. So externally, what you are applying this current, it should be more than corrosion current. Then only the corrosion can be prevented. Now, when you apply the current more than the corrosion current, so what will happen? It will become cathode. This metal will become cathode and it will become anode. Right? So it accepts the electrons from the DC source and reduction reaction taking place. It acts as a anode. It acts as a anode. Sorry, it acts as a cathode and it remains unaffected. So whereas this anode, so oxidation reaction supposed to take place, but since it is an insoluble anode or inert anode, in the directly will not take place in any reactions. You can see the more active metal. So anode before protection, cathode after protection. So before protection, so it is anode. After protection, so it is cathode. In this way, we can prevent the corrosion of this metal. So using impressed current method. So we'll see the best example are the real-time application of this impressed current method. So hull of a ship. So rust at the stern, which is made from the steel, which is closer to the manganese bronze propeller, and seawater acts as the electrolyte. So we'll understand one by one. Hull of a ship is the bottom of the ship. So rust at the stern means steel. Usually the body of the ship is made from the steel. So this stern is placed on the backside of the ship, and manganese bronze propellers are placed at the backside of the ship. So propellers need to be very stronger. So that's why manganese bronze alloys are used. These manganese bronze alloys are in contact with a steel. Steel is it is a body of a ship. When two dissimilar, so you see manganese and bronze are connected with steel. Then when two dissimilar metals are connected with each other, so according to galvanic corrosion, the metal which is having lower reduction potential taken as anode. So according to electrochemical series, steel has lower reduction potential. So whereas manganese bronze alloy is higher reduction potential. So in this case, steel acts as anode and undergo corrosion. So steel is the body of a ship, but we don't want to we don't want to so takes place this reaction. This reaction not supposed to take place because we want to prevent the steel, which is the body of a ship. What we can do? We can apply implicit current method. So what we are doing here? So we will take the the body of a ship or the steel. One part of this is connected to a reference electrode. We are taking a contact from the a body of a steel, body of a ship, so and we are connected to a reference electrode. So when you combine these two electrodes, so it will become, you can so it is called a controller. So what will happen? Why we have this one connection from the steel and another from reference electrode? What will happen? We can measure the corrosion current. So why we are measuring corrosion current? If you know the corrosion current, it will be very easy to supply power so more than the corrosion current. You can see when you apply a current more than the corrosion current to a this is what the implicit current anode, right? So when you apply a current more than that, more than the corrosion current, that is called a protecting current. So this implicit current anode, so what will happen? This implicit current is supplying protecting current to the steel. So when the current is supplying to the steel, it accepts the electron, reduction reaction taking place, it acts as a cathode and it remains unaffected. So it is prevented from corrosion. So steel or the body of the ship is prevented from corrosion by applying a protecting current. So this is what the real-time application, practical application of a implicit current method. You can see this mechanism is completely different from the sacrificial anodic method, because here you see we are measuring the corrosion current and it is completely automatic, fully automatic. We are not monitoring anything. So we'll see the examples or the major applications of this implicit current method. So what are the applications of this implicit current method? So these implicit current method are used in onshore pipelines, sea vessels such as ships, boats, boat propellers, and ship propellers and ruders, mobile or fixed offshore pipelines, production platforms, water heaters, oil casings, hull of a ship and boats, concrete bridges in seawater, storage tanks under soil or seawater. These are the main application. Now so like all methods has disadvantages and advantages. So similar way, this method also has its own advantages and its disadvantages. The main advantage is it is fully automatic. Fully automatic means automatically we can control the corrosion protection by continuously monitoring and varying the power required. If you know the corrosion, like if, for example, if you go to sacrificial method, so in sacrificial method, so anode, so more active metal has to be connected externally and it has to be monitored regularly, because if you're not monitoring the anode regularly, so anode dissolves, so you need to periodically replace it. If you're not able to replace the anode, so the metal to be protected will under corrosion. But here the case is different. Here no need of monitoring is required, so it is a self-automatic system, so automatically controls how much corrosion current is there, so how much extra power supply has to be applied. It is fully automatic system, no need to monitor regularly. And one more important is long-term protection. So once you install this implicit current method, so we can rely on even for more than 20 years. So once you installed, then it will become, so it is a long-term process, long-term production method. So it is a best method compared to sacrificial anode method. Need not replace the anodes. So here, so anyway, anode is inert anode we are using. So anode, there is no oxidation reaction at, and there is no corrosion at anodic reaction. So that's why need not to replace the anodes. But in sacrificial anode method, need to replace it regularly, because anode was so dissolvable in sacrificial anode method. Single installation required. So no need, single installation is enough. No welding requirement. So in sacrificial anode method, we are bolting a more active metal to the metal to be protected. So automatically, so welding is there. So when you are attaching, when you are welding, so there may be a high possibility of corrosion to take place. So these are the main advantages of implicit current method. Then what are the limitations? So it is a very sensitive component. Since we are connecting to the reference electrode, we are measuring the corrosion current. So therefore, it is a sensitivity component. It requires highly regulated control systems. So because we are using a core system, so then maintenance is required. So and it is expensive. Why it is expensive? Because so it is we are using a power supply. So we need to supply power source from externally. So more than the corrosion current. So that's why. So automatically this system will become so expensive. So these are the advantages and limitations of impressed current method. So I think now we are able to distinguish between a sacrificial anode method and impressed current method. So I'm ending this session here. Thank you.